They told us we were alone, but the universe whispers a different, terrifying truth. Billions of galaxies, trillions of stars. Where is everyone? This is the Fermi Paradox. In 1950, physicist Enrico Fermi asked a chilling question: where are all the aliens? Statistically, life should be abundant. Intelligent civilizations should be common across the cosmos. Yet, we hear nothing. No signals, no visits, just a profound, unsettling silence. From simple cells, intelligent beings arise. Technology accelerates, reaching for the stars. A Type 1 civilization masters its home planet, harnessing all its energy. A cosmic milestone. Type 2 harnesses its star's entire output, perhaps with a Dyson sphere. Unimaginable power. Type 3 dominates its galaxy, a vast empire spanning countless star systems. A galactic force. Given billions of years, some civilization should have reached Type 3 status by now. So why isn't the night sky ablaze with alien megastructures? Where is their light? One terrifying explanation: the Great Filter. A cosmic barrier no species can overcome. Perhaps the filter is behind us, the unlikely jump from non-life to replicating organisms. If so, we are incredibly lucky. We passed the test that extinguished countless others. Or, the filter lies ahead. A technological singularity, or self-destruction awaits all advanced life. Nuclear war, ecological collapse, rogue AI. Are these inevitable fates for intelligent species? Another theory: Earth is exceptionally rare. A unique cosmic confluence for complex life. Perfect orbital distance, a large moon, plate tectonics. Conditions essential for our evolution. Perhaps they are watching us. A galactic zoo, observing primitive civilizations untouched. A cosmic, prime directive, preventing intervention until we are ready. A silent guardian. A terrifying thought: the universe is a dark forest. Speak up, and you invite predators. Despite the silence, we listen. SETI continues its vigil, searching for any whisper. Projects like Breakthrough Listen scan billions of frequencies, hoping for a signal. We send our own messages into the void, a cosmic bottle hoping for a response. The Fermi Paradox remains humanity's greatest unanswered question. A profound cosmic mystery. But the silence compels us to look harder, to listen closer. The truth is out there. One compelling explanation is the Great Filter, a barrier preventing life from becoming interstellar. The filter could be in our past, the incredible unlikelihood of abiogenesis, or the leap to complex life. Perhaps we are incredibly rare. The filter was overcoming these early, immense evolutionary hurdles. Or the filter lies ahead. Advanced civilizations inevitably self-destruct through war, pollution, or technology. From plate tectonics to a massive moon stabilizing our tilt, Earth is a cosmic anomaly. Even Jupiter acts as a celestial bodyguard, shielding us from catastrophic asteroid impacts. Each unique factor multiplies, making the statistical probability of another Earth-like world incredibly low. Many believe advanced civilizations perish at their own hands, succumbing to global conflicts or weaponized technology. Unchecked industrialization and climate change could render planets uninhabitable before interstellar travel is achieved. Or perhaps the creation of an advanced AI or a novel technology proves to be their ultimate undoing. The path to technological advancement might inherently contain the seeds of self-destruction for many species. What if they are here, but choose not to reveal themselves? This is the zoo hypothesis. Perhaps humanity isn't ready for contact, deemed too primitive, too volatile, or simply not interesting enough. The dark forest hypothesis proposes a terrifying reason for the silence: fear. Any civilization broadcasting its presence risks attracting hostile entities, turning the cosmos into a hunting ground. Therefore, the safest strategy is silence. To be seen is to be eliminated. We might be looking for the wrong kind of life. Alien intelligence could exist in forms unimaginable to us. Their communication methods, or even their very existence, might be beyond our current detection capabilities. Life might not be carbon-based, needing entirely different conditions, making detection profoundly challenging. The sheer scale of the universe is staggering. Distances are so vast, encounters remain incredibly rare. Civilizations rise and fall over cosmic timescales. We might simply be out of sync, missing their brief existence. Advanced life might be a flash in the pan, too short-lived to cross vast interstellar distances. Yet, the search continues. SETI programs, exoplanet discoveries, and new technologies push the boundaries. Our innate curiosity drives us to keep asking, to keep listening, to peer deeper into the cosmic abyss. New observatories and missions promise unprecedented insights, refining our understanding of life's potential. The Fermi Paradox remains one of humanity's greatest unanswered questions, challenging our assumptions about life. Whether alone or surrounded by unseen intelligence, the paradox compels us to value our unique existence. Another hurdle, the evolution of complex cells with nuclei, a monumental step unique to Earth for billions of years. From single cells to multicellularity, a pathway to larger, more specialized organisms, another potential bottleneck. The Cambrian explosion showcased a rapid diversification of life, but this complexity might be rare elsewhere. The development of intelligence, language, and tool-making capabilities represents another significant evolutionary challenge. Reaching a planetary civilization capable of spacefaring technology is an immense, multifaceted accomplishment. Perhaps the filter lies ahead, in our inability to overcome self-destruction through warfare or advanced weaponry. Or perhaps civilizations succumb to environmental degradation, exhausting resources before escaping their home world. The rise of artificial intelligence could be a filter. An uncontrolled AI might render its creators obsolete. Extinction-level events, like asteroid impacts or supervolcanoes, could reset nascent civilizations. Even cosmic phenomena, like supernovae or gamma-ray bursts, pose existential threats to developing life. What if they are here? The zoo hypothesis suggests advanced aliens simply observe us from afar. They might impose a non-interference directive, allowing humanity to develop naturally without influence. Their intelligence might operate on an entirely different plane, making communication or even detection impossible for us. The sheer distances between habitable worlds might be too great for even advanced civilizations to traverse. Signals might be too weak, too brief, or too different from what we anticipate to detect. Perhaps advanced civilizations transcend their physical forms, existing as pure energy or digital consciousness. Such highly evolved beings might inhabit constructs like Dyson spheres, making them difficult to detect. Civilizations may rise and fall, leaving behind only ruins, long before we could ever find them. The rare Earth hypothesis argues that the conditions for complex life are exceptionally unique to our planet. Even the origin of life itself, abiogenesis, may require a highly specific and improbable set of circumstances. The long, stable period required for complex evolution on Earth might be an anomaly in the universe. Could it be that we are, in fact, alone? A singular, precious experiment in the vast cosmos. The dark forest theory proposes that advanced civilizations stay silent, fearing destructive contact. Any detected civilization is a potential threat, leading to a cosmic silence born of fear and paranoia. Our future may involve becoming the first to colonize the galaxy, if the filter is indeed behind us. The search continues, driving humanity to explore, to listen, and to ponder our ultimate cosmic destiny. One compelling explanation for the silence is the Great Filter, a hurdle all intelligent life must overcome. Perhaps the filter is behind us. The improbable leap from non-living matter to self-replicating life. Or the emergence of complex eukaryotic cells, a singular event fundamental to multicellular life. The Cambrian explosion, a burst of biodiversity, might also represent an incredibly rare evolutionary bottleneck. The development of complex intelligence itself, leading to technology and civilization, could be the filter. The transition from basic life forms to a species capable of interstellar communication is astronomically unlikely. If the filter is behind us, then humanity is exceptionally rare, perhaps even unique in the observable universe. But what if the filter lies ahead? A catastrophic event that nearly all advanced civilizations encounter. Self-destruction through warfare, perhaps nuclear, is a terrifyingly plausible filter for technological species. Environmental collapse due to unsustainable resource consumption or climate change could wipe out civilizations. Uncontrolled artificial intelligence, or a runaway nanotechnology, might also pose an existential threat. Cosmic catastrophes, like asteroid impacts or gamma-ray bursts, remain an external, unpredictable filter. Another solution, the sheer vastness of space and time. Civilizations may simply be too far apart. Civilizations might rise and fall across cosmic timescales, never overlapping enough to communicate. The zoo hypothesis suggests they are here, observing us, but deliberately avoiding contact. Or the planetarium hypothesis, we live in a simulated reality, part of a grander design. The dark forest theory proposes advanced civilizations hide, fearing others are hostile predators. Broadcasting our presence could be a dangerous act, drawing unwanted attention from unseen entities. Perhaps advanced civilizations evolve beyond physical bodies, into consciousnesses inhabiting vast digital realms. They might exist in forms or locations we cannot yet comprehend or detect with current technology. The search continues, driven by curiosity and the profound implications of finding an answer. Every new exoplanet discovery, every radio signal analyzed, adds another layer to the mystery. Maybe Earth is truly rare, a Goldilocks planet with an improbable confluence of life-sustaining conditions. The Fermi Paradox forces us to confront our place, our uniqueness, and our ultimate destiny. If we are alone, it places immense responsibility on humanity to preserve life and intelligence. Overcoming our own filters, like climate change or conflict, becomes paramount for our survival. If we are the first, then the cosmos awaits our exploration, our growth, and our future. The silence is not emptiness, but a profound question, echoing across the universe. Where are all the aliens? The answer remains the greatest unsolved mystery of our cosmic existence.